So after the short introduction of the parachute, let us start to analyze the model about the parachute which moves like a double pendulum. Before we start it, we first assume some parameters that we'll use soon. Mass of the blue ball, M1. Mass of the yellow ball, M2. Massless wire which named as are L1 and L2. Angles the two wires make with the vertical line be denoted as theta 1 and theta 2. Gravity is G, time is T. Position of M1 is x1, y1. Position of M2 is x2, y2. Now we can get two angular velocities omega 1 and omega 2 respectively to M1 and M2 in equation 1 and equation 2. And x1, y1, x2, y2 is these four equations. Now we derivative these four equations. We can get x1 prime, y1 prime, x2 prime, y2 prime. Now we can compute linear velocities for m1 and m2, v1, v2. Now we have many equations to use. How can we analyze this model? A good method is to use the gradient. What is the gradient? It's part of the gradient mechanic. In short, the gradient mechanic is a reformulation of classical mechanics. Its goal is to solve the Lagrange equations. But I think Lagrange mechanics is such a big field, so I will not introduce it here. If you want to learn, you can just Google. Today we just use the gradient as a tool. In this field, the gradient is denoted as kinetic energy minus potential energy. Then we can get the gradient. Then we use Euler-Lagrange differential equation. The goal of Euler-Lagrange differential equation is to get the solutions on the function for which a given function is stationary. For theta 1, we can get this equation and equals to 0. For theta 2, we can get this equation and is equals to 0. You can observe that we have second derivatives of theta 1 and second derivative of theta 2 in these two equations. So we can solve this simultaneous equation. Now we can get second derivative of theta 1 and second derivative of theta 2, denoted as equation 3 and equation 4. So we have equation 1, equation 2, equation 3, and equation 4. Now we can solve the head of the M2. Why this? Y2. Just use this for equation. Oh, sorry. We use Longe-Coulomb method. This method is like Euler method that make us can have approximate solution of ordinary differential equation. So we use Longe-Coulomb method to get this. And if we make this equation into y2, we can compare the y2 and y3. Y3 is the highest head that simple pendulum can reach. If we compare y2 and y3, we can know whether the double pendulum can reach the head same as or higher than the simple pendulum can reach if the initial angle of double pendulum theta 1 is smaller than simple pendulum theta 3.